All right, hey everybody, this is the speed, velocity, and acceleration problems. What I'm going to do is walk you through how to set up each problem, and then you'll just do the math to find the answer if you needed help. And I'm going to go pretty quick, so if you need to pause it at any time, just go ahead and do that. And if you have questions, then let me know. You can send me an email, whatever you need. So we'll get started. So number one, Pete is driving down 7th Street. He drives 150 meters in 18 seconds. So 150 meters, 18 seconds is our time. So speed equals distance over time. 150 meters divided by 18 seconds. That'll give you your answer. A person jogs 4 kilometers in 32 minutes, then 2 kilometers in 22 minutes, and finally 1 kilometer in 16 minutes. What's the average speed? So speed we don't know. Distance we have to add up all of our distances to find that the person goes a total of 7 kilometers. And for time, we have to add up our minutes, but then we also have to convert that to hours because it's asking per hour. So we find out that this is 70 minutes, and then we do a little bit of math. 70 minutes divided by 60 minutes in an hour gives us 1.17 hours. So the time we'll use is 1.17 hours. So speed equals distance over time. 7 kilometers divided by 1.17 hours is what you're going to do. Number 3, train travels 120 kilometers in 2 hours 30 minutes. What's the average speed? So speed we don't know. Distance is 120 kilometers. And time is 2 hours 30 minutes. But we can't use that, so we have to turn 30 minutes into hours. So it'd be 2.5 hours since that's 2.5. And speed equals distance over time. So 120 kilometers divided by 2.5 hours. That'll give you your answer. For number 4, a plane's average speed between 2 cities is 600 kilometers per hour. If the trip takes 2.7 hours, how far does the plane fly? So speed, distance, time. We don't know how far, but we know 600 kilometers per hour and 2.7 hours. So distance equals speed times time. 600 kilometers per hour times 2.7 hours. And remember, hours cancel out. So your answer will be in kilometers. Number 5, George walks to a friend's house. He walks 750 meters north. Then he goes too far, so he turns around and goes 250 meters south. And that takes 230 seconds. His speed per second. So speed, distance, time. We don't know. He travels 750 meters north plus 250 meters south. So in all, 1,000 meters in 230 seconds. So speed equals distance over time. 1,000 meters divided by 230 seconds. And remember, if you need to pause it at all, make sure you do that and figure out what's going on. That's okay. Number 6, there's a whole lot of information here. You have 3-minute passing period, and you're going from math to your locker, and then dropping off a paper at the office, and finally to science, and you walk at a speed of 1.38 meters per second. Will you make it to class in time? Assuming no other interruptions and only spending 15 seconds at your locker. Okay, so speed we are given. Students might be confused by the 15 seconds or the 3 minutes, but we are still finding time on this one. Speed is 1.38 meters per second, and our distance is the 63 meters plus the 51 meters plus the 110 meters. So in total, you travel 224 meters. So time equals, let's see, distance divided by speed. So 224 divided by 1.38 meters per second. Meters cancel out. So your answer will be in seconds, and then you have to add on whatever you get. You have to add on 15 seconds. And you'll be answering the question, is it greater than or less than 180 seconds? Because that's 3 minutes. So you want to know, do you make it to science class in under 180 seconds? Yes or no? Number 7, we're starting with acceleration now. So a roller coaster's velocity at the top of the hill is 10 meters per second. 2 seconds later, it reaches the bottom of the hill with a velocity of 26 meters per second. What was the acceleration of the coaster? So final speed, initial speed, and time. Since we're finding acceleration, we know, and you know what I like to do is I like to draw a little picture sometimes. So here's our roller coaster. There's the car, it's going 10 meters per second. It goes down the hill, and that takes 2 seconds. And then it's down here, and it's going 26 meters per second. Sometimes it's just helpful for me to put it all in place, because then I know, 10 meters per second is my initial speed, 26 meters per second is my final speed, so time is 2 seconds. All right. So final speed minus initial speed over time, you got 26 meters per second minus 10 meters per second over 2 seconds, which means we have 16 meters per second divided by 2 seconds. And our answer, you will find, and make sure your answer is in meters per second squared. All right, onto the back side now. A roller coaster is moving at 26 meters per second at the bottom of a hill, and then 3 seconds later it reaches the top of the hill moving 10 meters per second. What was the acceleration? And as always, final speed, initial speed, and time. Initial speed is 26 meters per second. Final is 10. And this time it took 3 seconds. Remember to draw a picture if you need to. Whoops, not an @ sign, just an A. All right. Final speed minus initial speed over time. So this time we have a final speed of 10. Initial 26 divided by 3. So you have a negative 16 meters per second divided by 3 seconds. So your acceleration, since it's getting slower, will be negative. Don't forget that negative sign. Number 9, a car traveling at 15 meters per second starts to decelerate steadily, and it comes to a complete stop in 10 seconds. What's the acceleration? Final speed, initial speed, and time. So it's traveling at 15 meters per second and slows down in 10 seconds, and complete stop means that it's going 0. So then we just put our numbers in. And we've got 0 minus 15 meters per second over 10. And just remember your answer, since it's getting slower, will be negative. Number 10, a red force car starts from rest and travels 3.82 meters in 2.71 seconds. What's the car's speed? And what's the car's acceleration? So we have to find a couple things. First, we have to find how fast that car is going at the end. So that's our speed, and I'm going to label that with a little f because we're finding the car's final speed, distance, and time. So whatever we get here will be used to find acceleration later on. So it travels 3.82 meters in 2.71 seconds. Speed equals distance over time. So we've got 3.82, 2.71. So now we have one of our answers, but this is also our final speed. So when we find our information for acceleration, this number actually goes here. So we fill that in, 1.41 meters per second. We'll know that it starts from rest, so its initial speed is 0, and the time is the same because that's how far it went and that's the time it took. So we're going to use the same time. Acceleration equals final speed minus initial speed over time. So 1.41 meters per second minus 0 over 2.71. I'm going to run out of space. 1.41 meters per second. There. Over 2.71 seconds. That'll give you your acceleration. All right, a peregrine falcon has been recorded going 108 meters per second in high-speed dive for 0.233 minutes. How far did the falcon dive, and if the falcon was originally traveling at 55 meters per second, what was its acceleration? So the first thing we need to find is the distance. Speed, distance, and time is what we need to do. All right, had to pause real quick, it was getting loud. Okay, so we are finding the distance traveled. So we know the peregrine falcon's going 108 meters per second, 0.233 minutes, which we have to multiply by 60 to get 14 seconds for our time. So distance equals speed times time. So 108 meters per second times 14 seconds. That gives us a distance of, I'm not going to calculate that for you. Okay, don't need that for the next part. For our acceleration, final speed, initial speed, and time. We know at the end it's going 108 meters per second and initially 55 meters per second, and that all took, we already found, 14 seconds. So when we do our final speed minus initial speed over time, we have 108 meters per second minus 55 meters per second, 14 seconds. So 53 meters per second over 14 seconds, and you'll find their acceleration. Fastest moving creatures. It's crazy. Okay, 12. Train moves from rest, that means 0, to a speed of 26 meters per second in 300 seconds. What's the acceleration? Final speed, initial speed, time. So we've got a final speed of 26 meters per second. 0 is initial. 300 seconds is our time. Plug it all in. 26 meters per second minus 0 over 300. For 13, same train, 26, and then it hits the brakes, and then after 5 minutes, 25 seconds, it comes to a stop. That's why you don't try and race trains in your car because they don't stop. It takes them a very long time to come to a complete stop. So you got to respect that. All right, our initial speed this time, our final speed this time, and all of that takes 5 minutes, 25 seconds. But we know we can't just leave it like that. So we have to turn it all into seconds. 325 seconds. So acceleration equals final speed minus initial speed over time. So we've got 0 minus 26 over time. Remember to put your answer in the negatives because it's getting slower. All right, and that brings us to number 14. So we've got which has a higher acceleration, a dirt bike that can go from rest to 8 meters per second in 3 seconds, or a car that can go from rest to 30 meters per second in 8 seconds. How much faster is the acceleration? All right, so then we have to pick one, and we have to find the difference between the two. So we're going to need a lot of space, I think. So this will be for our dirt bike, and I like to draw pictures. So it's got little fenders in the seat and the handlebars. It's a dirt bike. All right, so you have final speed minus initial speed over time. And for our dirt bike, it can go from rest to 8 meters per second in 3 seconds. So we'll go ahead and find that. Final speed minus initial speed over time. So we've got 8 meters per second minus 0 meters per second over 3 seconds. If we solve that, you get 8 meters per second over 3, which is going to be 2.67 meters per second squared. Now for the car, little car, windows and a door. All right, so for the car, final speed minus initial speed over time. We're going to solve this one too, but then you have to subtract them to figure out exactly how much faster the acceleration is for one than the other. Ooh, kind of ran out of space. All right, so 30 meters per second minus 0 over 8. 30 meters per second over 8 seconds. So you're going to have to find out how much more one of these is than the other. And we see that the car's acceleration is a little bit higher, but you got to subtract them to find out how much higher. And finally, number 15, a car is moving 40 meters every 12 seconds and increases its speed to 80 meters every 15 seconds to try and pass the semi. What is the car's acceleration if this process takes 11 seconds? So what this means is you have to find your initial speed and your final speed, and then find the acceleration for how long that took to change. So we have initial speed of going 40 meters every 12 seconds. So 40 divided by 12 is 3.33 meters per second. All right, so there's one of our answers. Let me circle these real quick. Okay, that's important stuff. So there's our initial speed. Our final speed is going to be 80 meters divided by 15 seconds. So final speed equals 80 meters divided by 15 seconds, which equals 5.33 meters per second. All right, so we're ready to use this equation of our final speed, 5.33, our initial speed, and our time, which is 11 seconds. So if we plug in all the numbers for our final speed minus our initial speed over time, we get 5.33 minus 3.33 over 11 seconds, which gives us 2 meters per second over 11 seconds. So the cool thing is, if you were to write this actual equation out of acceleration, it's going to be distance over time minus distance over time, but we would call this for initial, for final, and this would be for initial. So there's a whole bunch going on in that little equation. But there's the whole thing. You'll have to work out the math to find the answers to each of these. And email me if you have questions. But good luck.